Here we are at Lesson 2, which is entitled Moving in a Little Closer. The objectives for Lesson 2 are to introduce atoms and their parts and introduce the concept of the atomic number. Let's go to our text now. In Lesson 1, we said that chemistry is the study of matter and that matter is all around us. Find something near you right now that is made of matter. Write it down in the space there in your book. Now in the space below, write down to the best of your knowledge what makes up that piece of matter, or in other words, the ingredients that go together to make up what it is. As an example, let's say I chose a table. I could write down that a table is made of wood, it's got some glue, screws, paint, maybe some varnish on it, and maybe some little bits of felt under the legs, and maybe some hinges where the leaves drop down. So go ahead, write down what makes up your piece of matter. Now choose one of the items in your list. In my example, I'm going to choose glue. Now think about that ingredient and write down what you think makes it up. In my example of glue, I could write down, well, glue comes from bones, cow hooves, and water. Now choose one of those ingredients you just listed. For our example, I'm going to choose the water. Now write down what ingredients make up that ingredient. I could write down that water is made up of hydrogen and oxygen. Can you write down the ingredients of the ingredient you chose? As you can obviously see, we're getting into smaller and smaller bits of matter, and in the case of our example, we got down to saying that water is made up of hydrogen and oxygen. I hope these names ring some bells with you. Those are the names of two elements we introduced in Lesson 1. In our example, we eventually got to the point where we found ourselves naming elements as the ingredients of our ingredients of our ingredients. According to our definition, an element is matter that cannot be broken down into a simple form of matter. That it is a most basic form, which from what other things were made. However, in our study of chemistry, we can't stop here. In order to understand more fully the nature of matter and how matter reacts with other matter, we must learn what constitutes an element. In other words, what are the ingredients or components of an element? You may know that the ingredients of an element are called atoms. Atoms are what make up elements. The early Greek scientists who devised this theory used the term atoms, meaning indivisible or unable to divide again. This theory that all matter is made up of elements, which are made of atoms, is known as the atomic theory. Let's pause and review for a moment. In this lesson, we began with an exercise in which we took an object of matter and proceeded to analyze its ingredients. We then found the ingredients of those ingredients, and then on till we got to the point where the list of ingredients was composed of elements. We learned earlier that elements were the simplest form of matter. We also said that to fully understand chemistry, we had to go one more step. That step was to study the atoms which make up those elements, and that this study would be based upon the atomic theory. Let's move on now. To fully understand matter and how it reacts with other matter, we need to learn more about the ingredients of even the atoms. This lesson is designed to introduce you to the three basic ingredients of any atom, which are known as the neutrons, the protons, and the electrons. We can give these three components a scientific name. We'll call them the three subatomic particles. We won't go into great depth about the origins of the theories of subatomic particles. Like the development of the atomic theory, the developments of these theories are quite interesting, and you can go online to learn more about them. Let's begin our study of atoms by considering the general appearance of an atom. It's believed that atoms are like mini solar systems. The nucleus in the center of the atom corresponds to the sun in the center of our solar system. The electron cloud corresponds to the planets circling the sun. Within the nucleus are found two of the subatomic particles, the protons and the neutrons. Circling about the nucleus is an arrangement of electrons, which are like the planets of our mini solar system analogy. The electrons are considered to be moving at extremely high speeds. Therefore, if you could see just one atom, all you would see of its electrons is a blur, hence the name electron cloud. We said that within the nucleus you would find two of the subatomic particles, the protons and the neutrons. Although the neutrons and protons are extremely tiny particles, they make up most of the amount of mass of an atom. Now, mass is the amount of matter in an object. The electrons, on the other hand, make up only a tiny fraction of the mass of an atom. Let's look at the chart on page S22 in your book to examine the relative amounts of mass each of the protons, neutrons, and electrons have. If you look at the chart, in the first column, you can see listed are the three subatomic particles, the protons, neutrons, and electrons. In the second column over, you can see estimates of the actual mass of these three subatomic particles. Note that the protons and the neutrons have just about the same amount of mass, which is 1.7 times 10 to the minus 24th grams. Now look at the mass of an electron. Note that it's 9.1 times 10 to the minus 28th grams, which is much smaller amount of mass than the protons and the neutrons. Now, to bring this into perspective, look at the third column over. There you can see that the protons and neutrons can be likened to the mass in a cannonball. However, the mass of an electron could be likened to only the mass found in a ping pong ball. So together, if we were to look at the overall mass of an atom, we can see that most of the mass is found definitely in the protons and in the neutrons. Now, the number of subatomic particles in any one atom is the basis for the atomic number of the atom. Look at the periodic table on the next page in your book. Note that in each little square you can find an element symbol, an element name, and two numbers. The number in the upper left-hand corner, which is the whole number, is called the atomic number. The number beneath the element symbol and name is the atomic mass of the element. Find the element C for carbon. Note that carbon's atomic number is 6, which means that one atom of carbon contains 6 protons, 6 neutrons, 6 electrons. This holds true for the rest of the elements in the periodic table. If you could sample a few atoms from any element of the periodic table, all of the atoms in that sample would generally have the same number of protons, neutrons, and electrons. We only say generally because sometimes the number of neutrons can vary up and down a little bit. However, all in all, we can say that the atomic number, most of the time, is equal to the number of protons or electrons or neutrons for that atom. Let's look at an example here. What is the atomic number for helium? So find helium on your periodic table. Remember the symbol He. You'll see it there over on the far right on your periodic table. The atomic number for helium is 2. So how many protons does an atom of helium have? If you said 2, you're correct. How many neutrons will it have? Now, again, 2 would be the correct answer. How many electrons does an atom of helium have? If you said 2, you're exactly right. Let's try another example here. How about oxygen? How many protons does an atom of oxygen have? So first thing you do, find oxygen on the table. Remember the symbol for oxygen is O. Look at the atomic number there. The atomic number for oxygen is 8. Therefore, oxygen will have 8 protons. It will also have 8 neutrons and 8 electrons. Let's pause now and review what we've learned so far in this lesson. We said tiny bits of matter are called atoms. We said that atoms are thought to look like tiny solar systems with the nucleus in the center and an electron cloud around it. We said that atoms are made up of subatomic particles known as the protons, neutrons, and electrons. We said that the protons and neutrons are found in the nucleus of an atom, and electrons are found circling around in orbits as similar to planets circle our sun. The atomic number of an atom tells how many protons, neutrons, and electrons are present in that atom. And we said that most of the mass of an atom is found in its protons and neutrons, and that electrons have a very tiny amount of mass. Practice the concepts you've learned in Lesson 2 by turning to the practice pages found at the end of Lesson 2 in your student textbook.